this video, we're going to do another u substitution problem, this time involving trigonometric functions. So we've got 5 raised to the power of cotangent x times cosecant squared x dx. I have no idea what this function might model, or what it even looks like. But I remember that the derivative of tangent is secant squared, so there's probably a similar relationship between cotangent and cosecant. So what I'm going to do is examine the derivative of cotangent and see if we can use that for our u substitution in order to cancel out our cosecant and solve the integral. Cotangent equals the reciprocal of tangent. Tangent equals sine over cosine. The reciprocal of tangent is equal to cosine over sine. Next, we'll apply the quotient rule to cosine over sine. Derivative of cosine is negative sine times the denominator, minus the derivative of the denominator, cosine, times the numerator, all divided by the derivative of the denominator squared. We'll factor out the negative here and condense down our sine times sine and cosine times cosine. Sine squared plus cosine squared is a Pythagorean identity. This is equivalent to 1, leaving us with negative 1 over cosine squared, which is of course equivalent to negative cosecant squared. So we found our cancellation. So having chosen u to be cotangent of x and found the derivative of u with respect to x being negative cosecant squared x, we're ready to do our u substitution. Plug in u, solve for dx, plug in dx, perform your cancellation, and then rewrite the integral. All we've got left over here is a du over negative 1, so that's 5 to the u times du over the negative 1, or negative 5 to the u du. This is the power of u substitution. It's so much simpler to solve the integral 5 to the u than that complex set of trig functions that we started out with. Next, we would address the boundaries or the limits of our integration, but there are none there. This is an indefinite integral, so we can go right ahead to solving. We get negative 5 to the u over natural log of 5, and let's go ahead and convert that back to a function of x. And there you have it, an example of u substitution when applied to trigonometric functions.